Hi, students. All right, so last night's homework was to read and take notes over impacts on the atmosphere. Human activities do impact our atmosphere, and clean air is really important for us as well as other organisms, all organisms. So it started out by telling you why clean air is important for everybody. Anything that breathes takes whatever's in the air into their body. So if you have a bunch of chemicals, carcinogens, things that cause cancer, if that's in your air and you take it in, you're exposing your body to those things. The word particulate matter was in there. Like if you go camping and you start a campfire, have you noticed the little particles that come up out of the campfire, little particles? That's particulate matter. That's one example. When a volcano erupts, that's a natural way that particulate matter gets into the environment. Have you ever seen the sun coming into the house and you see things floating in the air? All kinds of particulate matter. It could be pet dander. It could be your dander. It could be things that are just around the house. It could be little pieces that have come off my scarf. I mean, there's little particulates just floating around. If you turn off the lights and just let the light shine through the house, you'll see particulate matter. It's everywhere. Okay? So that you want to be careful of what those particulates are. Are they synthetics? Are they just natural dusts? So particulate matter is the little pieces that are floating around in the air that we take into our bodies. Okay, so I feel confident as 8th graders that you have been into a city and seen smog. So photochemical smog is when nitrogen and carbon compounds in the air react with sunlight, and it gets really thick and dense. And when we watched Racing Extinction, we saw some of that photochemical smog, like in China, how dense it was, how heavy, and that also has particulates in it, and it has cancer-causing chemicals in it. Is very unhealthy. It has less oxygen that you need and more of all these chemicals and particles in it, obviously, because it's so dense you can see it. That can't be good. I noticed when I lived in California for a short time, the smog in Huntington Beach in the city area, because that moisture holds it down on top of the fact that there were a lot of vehicles, and they had stricter, this was in the early 80s, they had stricter emissions, car exhaust emissions than we do in the Midwest because the high population in the city. So the vehicles had higher standards that they had to meet. And matter of fact, my vehicle, because I had brought my vehicle from Indiana to there before I could get my driver's license there in California, I had to upgrade my vehicle exhaust to meet their standards, which were higher. So, but even with all of that in place, you could still, there were a lot of mornings where the smog was just sitting on you, and they would have to power wash their buildings quite often because it would get coated with brownish, yellowish. Ugh. So, photochemical smog, you don't want to take that in. You might have noticed also in that video that a lot of people, and this was pre-COVID, it was 2015 in that documentary that was recorded in 2015, a lot of them were wearing masks because the air quality index was unsafe. So the ones that take that seriously or even have slight health impairments had masks on, and a lot of them, that's just part of their day-to-day thing. They just wear masks so that they don't get all those particulates and stuff inhaled. Acid precipitation is precipitation that has a low pH. On the pH scale, in the middle of the scale, it's a spectrum, it's a line. In the middle of the scale, around 7 is neutral. It's not acidic, it's not basic. So as you move higher numbers, you get more basic. And actually, some people think that basic isn't a problem. Well, basic can be corrosive as well. So a high base number can be bad. So the neutral right around 7. And then the lower the number, the more acidic it is. So something that has an acid level of 3 is much more acidic than something that is a 6. The 6 is close to neutral. Hopefully you follow that. So acid precipitation is rain or snow or sleet or any of those, any precipitation that falls that has a low pH. That does damage. You could look it up. There's pictures of statues and stuff, especially in the along the Canadian border, because we burn fossil fuels, we create a lot of acid rain by burning fossil fuels. We burn coal for our energy, mostly burn coal, and that creates acid rain. So, and the way the air moves and travels, it takes it on up northeast, and it can fall in the lower parts of Canada and stuff, and you can actually see the acid rain is starting to destroy Bedford stone. Stone statues have pockmarks all in them from rain being that acidic, because when you mix an acid with a base, and those statues are made out of a base, a pH base, when you mix that, you get a reaction, and it takes away that base, so it eats away at it. So acid precipitation, talked about that. It also damages trees and bushes and stuff. It can actually eat away. It can be so acidic it can eat away at the foliage. It also ends up in our water. Think about that. When rain falls, it ends up in our water. It ends up in our groundwater. It ends up in our rivers and lakes and ponds and streams. We don't want to increase the acidity of those. Can you imagine being an organism? You saw in Racing Extinction what's happening to the shells. The shells are a carbon, which is a base, and they're dissolving in the acidity. So acid rain also participates in that. Hopefully you read under the CFCs heading on page 324. Hopefully you paid attention to that, because it talks about how CFCs used to be used. Those are chlorofluorocarbons in the song. CFCs, chlorofluorocarbons. It's just easier to say CFCs. But those were used for refrigeration. It was a chemical that was used because it would remove heat and take it somewhere else. It was also used in aerosol cans. You know, the big hair back in the 80s and 70s too. In order to get that, you had to have really good aerosol hairspray. Well, the aerosol that was in that was a CFC. And what that was doing is eating away at the ozone. It was reacting with the ozone. So that's really dangerous to breathe. It also then created, as it moved on up into the atmosphere, into the layers of the atmosphere, it was creating a hole in the ozone. So it actually became a big global issue. All the countries that are part of the Kyoto treaties, all the countries had to start addressing this, because you guys, if you have a hole in the ozone also protects us. It's that thin layer that protects us from UV. So if we get too much UV, we get skin cancer. And then skin cancer metastasizes and becomes cancer everywhere in your body. So you don't want to start with skin cancer. You don't want to start there by being overexposed to UV radiation. That's why you're supposed to put on sunscreen and stuff like that. Well, it was creating this big hole, and they were finding out that these CFCs could last 60 to 100 years, creating these holes in the ozone, and everybody's using them, and refrigeration production is up, and cars are now getting air conditioning, and all these things are using CFCs. So in 1970, they created the Clean Air Act, and it passed in the United States. The problem was they had to come up with something else, because you're not going to tell all the population that, oh, sorry guys, no more air conditioning and no more refrigerators. That's not going to happen, right? So the scientists had to get to work to find something that could replace the CFCs that were being used, still create refrigeration and not be harmful to the ozone layer or a chemical that was harmful to people or animals. So they had to get to work on it. That was in 1970. It was around 1996 when it was actually starting to be enforced. It said, okay, from this point forward, you cannot use a CFC. If you make an air conditioner, you can't use CFCs for your coolant. You can't. It's no longer legal. You can't sell those products. So that's 26 years from the time that it was enacted to the time that they actually put their foot down and said, nope, you can't sell anything that's got CFCs in it. So if you have like something from 1996, it still has CFCs in it. But if it's from 1996 and on, it's not supposed to. But not everybody follows the rules until they get caught, right? We know that. Sometimes you guys are that way.